Hello everyone, I am Mrs. Usha Jadhav, Assistant Professor, Department of ENTC, D.Y. Patil College of Engineering, Akurdi. My topic of presentation is Role of Semiconductor Industry for Environment and Sustainability. As many of the engineers are from the domain of electronics and telecommunication. So let us discuss that what is the role of ENTC engineer for environment and sustainability using various semiconductor chips, that is integrated circuits. The semiconductor industry plays an ever increasing role in society, providing microelectronic components called chips that are used in a wide variety of electronic applications. The rapid increase of the production of chips is responsible for considerable effects on the environment during the different phases of their life cycle. So, by considering the various phases of life cycle of various integrated circuits, we are going to divide this life cycle into the various stages with respect to the environment and sustainability concepts, like what are the environmental awareness of integrated circuits, environmental standards of chips, sustainability awareness of integrated circuits, and sustainability standards of these chips. So in today we are going to discuss only about the environmental awareness of our integrated circuits. So thus this presentation proposes a set of environmental indicators that take into account the most serious damages induced by various integrated chips in electronic devices. So the outline of my presentation is use of semiconductor devices, that is chips. Second one is what are the different environmental indicators. Third one is what is the environmental impact of these microelectronic chips, and conclusion. So let us discuss that what are the different uses of these microelectronic chips. So as everyone, with the advances in technology, especially the different industry standards are given by these semiconductor devices, like International Technology Roadmap of Semiconductor. So as per the various standards or as per the ITRA standards, these semiconductor devices are used in various applications, like these semiconductor devices are used in computers, they are used in mobile phones, various electronic devices, like the day-to-day we are going to use the tea coffee vending machines. It is used, these integrated circuits or the chips are used in the cars, especially in a dashboard consist of the microcontroller. It is used in the various types of ink cartridges, example in printers. There are various kinds of light bulbs which uses the integrated circuits, which is used especially for decorative purposes. There are medical applications. The most important now in a COVID-19 situations, how we can use these semiconductor devices or the chips for the medical applications, which will be helpful for us to make the distancing amongst the various peoples. Now let us discuss about what are the different environmental indicators of this semiconductor industry. The first one is a resource depletion. So the example of this resource depletion include deforestation, soil degradation, and overfishing. Deforestation is when we cut down the trees faster than they can grow back. This happens because of logging and land clearing for agriculture, ranching, mining, and oil propagation and oil perspective. Now the second indicator is eutrophication. So the eutrophication is the process in which legs receive nutrients like phosphorus and nitrogen and sediment from the surrounding watershed and become more fertile and sharp. The additional nutrients are food for algae which grow near to your water area and fish. So, the more eutrophic a lake is, the more living organism it sustains. The most common nutrients causing eutrophication are nitrogen and phosphorus, the main source of nitrogen pollutants in runoff from agricultural land, whereas most phosphorus pollution comes from households and industry, including phosphorus-based detergents. What is meant by this eutrophication? It is the process by which a body of water becomes enriched in dissolved nutrients such as phosphates that stimulate the growth of aquatic plant life, usually resulting in the depletion of dissolved oxygen. So, the main indicator in case of semiconductor industry is an eutrophication. Next, third indicator, environmental indicator, is water stress. Let's take an example how this water stress is used in the semiconductor industry or the chip. For example, as everyone knows that grape, which is a fruit used having a maximum content of water. So these grapes require very precise amount of water to produce fruit of just the right sweetness. So we can use this chip in a grape to find out how much of amount of water it will produce, which will just increase the right sweetness. Now the fourth indicator is nothing but the toxicity. So this toxicity that researchers have made a liver chip, the liver which is available in a human body, which is able to demonstrate the toxic effects of drug candidates and compounds in human patients. So the use of this chip in a human body will find out the toxicity content. The fifth environmental indicator is summer smog. So what is smog? Smog is a type of intense air pollution. So the recent developments in the organic of chip technology, as everyone knows that the semiconductor industry is evolution of the integrated chips, and there is a demand right now on a development in system on chip. So along with this system on chip, there is a organ on chip technology is used for environment and sustainability. It can be used to study air pollution. So organ on chip allows determination of pollutant toxicity and speeds up the development of novel pharmaceutical drugs. So it is very important that this organ on chip will find out the air pollutant contains in a human body also. The last environmental indicator used for your semiconductor industry is local electrical consumption. So the most recent advances in artificial intelligence systems such as speech or face recognition programs have come courtesy of neural networks, densely interconnected meshes of simple information, processors that learn to perform tasks by analyzing huge sets of training data. But these neural nets are large and their computations are energy intensive. So they are not very practical for handheld devices. As everyone knows that the smart devices like your smartphones, which consist of Android operating system, having the multiple number of your the applications or the apps that rely on your the neural nets simply upload data to internet servers which process it and send the results back to the phone. So there is a lots of energy consumption takes place in case of your the smartphones or our the mobile phones. So this is a very challenging task, the use of your the semiconductor devices, how to make it more environmental and sustainable with respect to these various indicators like resource depletion, eutrophication, water stress, toxicity, summer smog and local electrical consumption. So let's pause the video for 1 minute and please write the answer on in your the notebook. This is the first reflection spot. What are the environmental indicators for semiconductor industry, which is just explained. So let us take what are the different impacts of these environmental indicators which is used in a semiconductor industry. So if you see that the life cycle of this semiconductor industry is divided especially into two parts. One is front end and the back end. So front end indicates your the design center while back end indicates the manufacturing unit. So in a design center and the manufacturing unit, so to fill the gap between this, so we are using these various steps like manufacturing, transport, use and end of life. So we'll take especially the maximum that is the impact of this semiconductor industry or the takes place in a back end, especially in the manufacturing unit. So you can observe here the power management for telecommunication from the first figure that the 58% of your the manufacturing power management, 58% of your the carbon dioxide emission takes place during manufacturing, while 39% during the transport and then followed by 3% during its use. Similarly, if you see that as we are using the televisions in day-to-day life, which consist of the various security card in a set-top box. So 34% of our carbon dioxide emission takes place in case of your the end of your the life. 24% is its use, in 42% in the transport and 42% in your the manufacturing. Similarly, for a microcontroller which is used in the dashboard of our cars, where 69% of our the that is carbon dioxide emission takes place during manufacturing, 24% during transport, 7% during its use. Similarly, we are using the various types of memory like primary memory and the secondary memory in the devices. So this memory also will emit, memory chips also emits the various types of the carbon dioxide emission. Like during manufacturing it emits 89%, 6% during transport and some percentage during the use of its devices. So this is just an outline of the carbon dioxide emission takes place in the manufacturing or during the use of this the chips throughout the life cycle of the semiconductor IC. Now pause your video for 1 minute and answer this reflection spot 2. At which stages of life cycle of microelectronic chips carbon dioxide emission takes place? So we conclude here that a standardized method for the environmental characterization of microchip technologies is necessary to compare the performance of different products and specify the product profiles. A suitable set of your life cycle assessment indicators strongly contribute to increase the life cycle knowledge of the chips. So thank you very much.